All right, so we're going to learn circuits.
Yeah.
All right, so tell us about circuits.
You got to have three basic things to have a functioning circuit. You got to have power, you got to have path, and you got to have load, right? So, and we're going to start off very, very simple. So in this mock-up, we're going to pretend that this is our battery, right? So we have a positive side and a negative side, very, very simple. It's obviously connected down. You can't see out of frame. It's connected to a jump pack. But to mock up and kind of make this simple, this little guy right here is our battery. So we have power and we have ground. In electrical, we refer to the positive side of the battery as our power side and their negative terminal as our ground side, right? For easy understanding.
And we're dealing with a DC circuit.
DC circuit, 100% DC circuit.
Yep.
So this is a perfect way to learn wiring, is to start off with DC. I don't recommend ever starting off with AC. Like you go over to your kitchen counter and you're like, I'm going to play with this little terminal inside. Don't ever play with the AC. The voltages are much higher and you can hurt yourself really bad. So we're going to start off with DC.
DC 12 volt circuit.
DC 12 volt, I can touch both sides. I have no concern of getting hurt. Not going to get hurt, right? So in this example, this is my battery. And so as I said, to have a circuit, you have to have power, path, and load. PPL, power, path, and load. So here's my power, and then I have a light bulb. So my light bulb would be my load. Okay. Now, if I were to flip the switch on, obviously the light bulb's not going to turn on because I need to supply path to it, right? So I'm going to color code the wires, and I don't know how well the color will come across on video, but this is a red wire. I'm just doing it for OCD, right? So I've got my power side. If I attach it to the light bulb, will it light? No, it won't, because it needs a ground side too. We need to flow current through the bulb. As I was explaining on the video, that current has to go from one side of this battery through the load over to the other side of the battery. So we need our ground side. So I'm going to take a black wire. I'm going to attach it to the other side, and the bulb should illuminate, as it did. Yay, we have success, right? So we have power, we have path, and we have load, okay? Well, that's all well and good. If I was to attach this to a battery, my light bulb would be on all the time. That doesn't do me any good. I need to be able to control it. I want to be able to turn the light bulb off. So I need to add in a switch. So here's my switch. We'll kind of move it like this, right? And I'm going to now run power to my switch. My switch is like a drawbridge. Right? It allows current to flow across it. I'm now going to run from my switch to my load, and as I flip the switch, now I can control the light bulb. We've just added a layer of complexity. Okay? We've now just complicated this very simple power, path, and load that we had before. We added a potential fail point, but we need it because we need it for control. I said the magic word, fail point. Circuits fail, which is why we want to protect our circuit. We want an insurance policy for our circuit. So now we got to further complicate our circuit in order to protect it. I know that kind of sounds ironic. We need to add in a fuse, right? And this is a simple, basic fuse, which has an input and an output. And across that, the center of that fuse is what's referred to as an element. That element is a very thinner gauge than any of the wiring in the circuit. So if amperage increases in this circuit, if there's a short or something else, that element will burn. It'll burn to open and protect our circuit. Because if not, we're going to let, what they say is, we're going to let the smoke out of the wire. And we don't want to do that.
So like a cotter pin. That will break before the before the drivetrain or whatever. Yeah.
Exactly. So now what we're going to do is we just further complicated our circuit. We added more connections, right? As you guys can see, we've just made the power side or the positive side of this circuit a lot more complicated than the simple ground side, right? So there's more going on. So now when we turn this on, everything's working just fine, right?
Yep.
Now, we built this circuit with protection in mind because a circuit can fail. And when it fails, obviously it can fail in one of three ways. You can have an open, you can have a short, or you can have high resistance. I'll get into that in a minute.
Okay.
Before I get into that, though, I'd like to talk about ground a little bit more, if that's okay.
Yeah, please. And real quick, so if you have your bus system, and again, this is sort of your house battery. So this is your house battery, 12 volts, and then most of the time they have like power centers in your bus that you can use, and it will house kind of your fuse and your battery, and then it will go out of that to the whatever switch you're running, and then to whatever kind of lights, or maybe your 12 volt water pump if you're doing that. And then we're going to talk about grounds.
Yeah.
Sure.
Your power distribution is super important.
Yeah.
Having that ground or that power lug where it goes in and then it splits off into all your devices, Very important, especially if I were, and I'm not a Skoolie, I have never built one, but I hope to maybe someday with your tutelage. I think if I were to do the electrical side, I would probably sit down and really get kind of very systematic on how I would build my electrical circuit. Like I would say this number fuse will power these things, and I would want to start off kind of pen and paper and determine that before I begin.
Absolutely. Definitely talk about ground.
So ground. It's so confusing because we think ground. We're not ground. We're standing in our bus. The ground's out there under the tires, and ground is kind of a general term that we use. This is referred to as the ground side. Obviously, this bulb has 2 wires now leading back to the battery. Obviously, with the power side, much more complicated. I don't need to have a wire, right? I can use the metal in the bus. The bus itself is a conductor, sure, bust it out. So this is a little piece of metal to kind of illustrate this point. We're going to remove this wire, our ground wire, and we're going to pretend that this is the chassis of our school bus, okay? My battery is already attached to the chassis of the school bus, and we want to make sure that we attach the negative side of the battery and bolt it somewhere with some really heavy gauge, which is confusing when we talk about wire gauge. The lower you go in numbers, the thicker the wire, right? So an aught gauge wire or a 1 or a 2 gauge wire is recommended anytime you're doing any type of electrical stuff. So I want to bolt that to the chassis. Now, because this is a conductor of electricity, I can take a very short wire from my load, which is my bulb here, and I can simply attach it and it will work, just like before, right? Because the current is carrying through the actual chassis of the bus. So that's our ground.
And this is awesome because when I did my bus, if you saw when I did the ceiling, all my lights in the ceiling, rather than running ground all the way back to the battery, runs right to the ribs in the ceiling of the bus. And so now I don't need to really account for that long wire in the circuit to have a higher gauge, and also uses a lot less wire. Again, you get this tiny little piece rather than running all the way back to the battery. So, and the ribs ultimately go to the frame of the bus, and then my battery pack in my power center is negatively grounded to the chassis anyway, to another rib essentially. So yeah, really important concept.
Absolutely. So right now we have power, we have path, and we have load, but we've complicated it, right? That's why I wanted to add these things in to still keep us on track, but understand that nothing's changed. We still have power, we have path, and we have a load. And that's kind of the important piece. Now, as I said earlier, our circuit can fail in 1 of 3 ways. So I know we're talking about building, and that's important, but we have to build our circuits expecting them to fail because they will someday. And who's going to work on them, Ted?
You're such a negative.
I'm such a negative.
You're being so negative, Tone.
Who's going to work on your circuit when it fails?
Just us. Nobody else works on them. We have to do it ourselves. That's why we're building these Skoolies.
Exactly. So you know that the future you is going to have to fix this.
The future you.
So you want to make sure that you understand.
This is a letter to our future self.
This is a letter to our future self. We want to build it right from the beginning, so that way we're not stumbling around at some campground at 2 in the morning trying to make our margarita because it's been a long, hard night. We want that blender to function. So circuits can fail in 1 of 3 or 3 ways. We can have an open. Now, when I flip this switch, I'm creating a manufactured open. Right? I want that to be open. I'm creating a drawbridge. Current can't flow across the switch. Well, what happens when you hit that bump, as you enter that speed bump in the campground that you didn't see, and your ground comes loose, right? When I go to power this on, that's an open. It's a non-manufactured open. I need to be able to find that, right? So I'm not going to get into the diagnostics heavily right now. I can, but I think what's important is we want to first just talk about how they happen. So this is an open. The other type of thing that can happen, and opens can happen on the power side, opens can happen on the ground side. Another type of failure or fault would be a short. Now, shorts there's 2 types of shorts. Did you know what the 2 types of shorts were?
You told me and I forgot it already.
They're cargo shorts and jean shorts.
That's right.
No.
Board shorts.
Board short. Oh, dang.
Yeah, don't forget those. There's a whole bunch of shorts.
Here we go. I'm in trouble. No, there's 2 types of shorts. We have short to ground and short to power. Right? Now, to really talk about shorts, I have to make this circuit a little different, a little bit more complex, so that way you will be able to understand. So I'm going to add another switch here. And this is really common on how your circuit will look. Off of my fuse, I have this one fuse is going to power this separate kind of circuit that's in parallel with this one. And this is just a different light bulb. And it doesn't matter which way my switch is. This switch, instead, I'll keep it simple so that way it's uniform. Flip it upside down so that way when I flip it up, it'll be on, right? And I will ground this bulb. And now I have two circuits that I can control independently of themselves, right? Mm-hmm. I have a light bulb up top, which is a little dimmer. It's a different bulb, and the one on the bottom, which is a little brighter. But these two switches control them. The first type of short is the one we always think of, right? And that's short to ground. The electrons waiting at this battery would like nothing more than to be on the negative side, right? They want to be over there.
I want to go over there.
And you could argue with me and say, well, actually, technically, the electrons travel from the negative to the positive. I'm not going to get into conventional versus electron theory. We're going to stick with automotive and Skoolie understanding, where positive to negative, right? Just so we're consistent.
Yep.
So they want to be over there. You've got these electrons that are on one side of that wall. They're listening and they can hear everybody having fun. They can hear blenders running. They want to bust through that wall like they're the Kool-Aid man. But they can't. They have to go through this engineered thing before they can get over there, right? So if you give electrons an opportunity, and we're going to use this wire, if this is obviously the power side of this bulb and that's the ground side of this bulb, if I allowed the electrons, and my switch is off right now, so nothing's going to happen. But if I flip this on, we'll wait for just a second. We'll demonstrate that in a second. If I were to flip this on, instead of going through the load, electrons are going to skip the load and they're going to go around it. And if there's no resistance, that is considered a short circuit. We're going to have, instead of quarter amp of current, we're going to have thousands of amps of current. And that's going to cause a real big problem for our battery. That's going to cause a problem for our wiring. And we're going to let all the smoke out of the wires, and we're going to have a big problem. Yeah. That's why we put this fuse here. So what I'd like you to do is we're going to zoom in on this fuse, and I'm going to intentionally short the circuit so you can see what happens when this goes on. So I just flipped the switch on, and now that the switch is on, the circuit is shorted. Now that we've just restored the circuit back to functioning, we took the short out and all of that. Shorts can be really difficult to find, and we'll show how to a quick little diagnostic procedure here in a minute. But right now, the last one we're going to demonstrate is high resistance, and this is the one people don't typically think about. So high resistance can happen usually at your battery. And if you've ever opened up the hood on your car or whatever, and you've seen your battery, you see these fuzzy kind of growths that happen on the battery. Those fuzzy growths that happen, that's acid leaking out of your battery, and it can climb up into the wire, kind of like you have an oil lamp over there. Just like an oil lamp wick will leach up the oil into the wick, these wires will actually leach that acid into these strands of wire, and that acid will start to eat away at these strands. So let's say there were 6 or 7 strands of copper in this wire conducting electricity. Mm-hmm. Well, that acid just burned away 5 of those 6 strands. So there's only 1 strand left. Will the light still turn on? Maybe. Yeah. So what I did was, on this example, I created an actual wire with an ohm of resistance in it. So this wire is not okay. Right? Yep. As you can tell.
It's not okay.
It's ready to have a baby.
Yeah.
Right? So we're going to attach this wire just so you can see what it does. So this wire has extra resistance in it. Yep. So when I turn on this light bulb, a moment ago, you probably remember how bright it was. When I turn it on now, it looks like it's working, right? But what I'd like you to do is just kind of watch that light bulb when I short out this high resistance wire. So I'm going to put a good wire in its way. Just kind of watch how that light bulb will change. You can see how it's getting brighter and dimmer, right? If I turn on this one too, you may even see it even more. You can kind of see how they...
Which is how dimmer switches you talked about.
Correct.
But they don't work with LEDs that well.
They don't. You have to put
a special dimmer switch. Yeah.
So
I learned that the hard way, by the way.
Yeah. So you can see how they're flickering. Well, right now, if you're running your circuit, you're none the wiser, right? If that was a motor that spins and that needs to spin at a certain RPM, I'm going to go back to the blender because that's all I got in my head right now. You've got me thinking about margaritas. If that blender isn't going to spin at the right RPM, Jimmy Buffett's going to be very disappointed.
He's going to be very disappointed.
So we need to make sure that we eliminate this high resistance.
Yep.
So, and that usually happens when you have a battery terminal with a lot of corrosion on it, the corrosion grows into the wiring and you have an issue. That can happen usually where any terminals are, and the terminal is where a wire connects to something. That's the ending of the wire, we call it a terminal, it terminates. And I always like to check my terminals. I like to make sure my terminals are clean. I like to make sure my terminals are tight. Those are two important things when we're checking our wiring. So once again, future you're trying to diagnose. I know that my battery has plenty of voltage, but the device isn't working correctly. Maybe your problem is in the path. It's not the power, but it's the path. Maybe your problem is the load, right? So those are the types of things that I check. So those are your 3 types of circuit faults.
Cool.